Hi guys, so now let's look at chapter 2, reasoning and proofs. So let's get into it. First, section 1 on using inductive reasoning. Basically, inductive reasoning is basically finding patterns, and I think this would be something you're already familiar from Algebra 1. But let's look at what it really is. So a conjecture is an unproven statement that is based on observations. And you can use inductive reasoning to find a pattern in specific cases and then write a conjecture for that general case. So something simple would be like the case of one in this kind of pattern, we would say the conjecture would be there's +2 at each number, right? That would be your conjecture for the pattern of that statement. And I think you can get the examples by yourselves, but let's look at this proven conjectures, right? When you're trying to prove someone wrong, even in real life, you're trying to give a counter example. When your friend says, for example, that the only type of dog is a Maltese, you can say that there's a golden retriever. That would disprove the conjecture, right? And that would be something like a counterexample, which is a specific case for which the conjecture is false. And that's the same for math. So that's pretty straightforward. Let's look at two quick problems here. Look at number 11. So if you see the pattern here, there's an increase of 3, increase of 6, increase of 9. What do we see in common? There's an increase of 3 per number. And we can thus question that the pattern here would be n plus 3. In this case, n being 3, plus 3, plus 3, and so on and so forth. Let's look at number 22. So what's the first number in the pattern, right? You know that 81, 243, and 729 are all powers of 3, right? 3 to the 4th power would be 81, 5th power, 6th power, and so on and so forth. That means that here would be 3 to the 3rd power, 3 to the 2nd power, and 3 to the 1st power. The first number in the pattern would be 3 to the 1st power, aka 3. So B would be the answer. Now moving on to 2.2 and analyzing conditional statements. So a conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. And when a conditional statement is written in if-then and is written, it has to be in if-then form. So the if part would be the hypothesis and the then part would be the conclusion, right? So if you've done like science the hypothesis in your science classes, or when you did Stanford, you would know that how a hypothesis basically looks like, and that is an if-then form. Something would be like if a living organism has 46 chromosomes, then their human would be a good if-then form statement. But now let's look at negation, right? Basically, negation, like the name negate, is saying the negative or opposite of the original statement. So if the statement is that dog is white, then you would be saying the dog is not white, and that would be the negation of that statement. But let's look at other like conditionals that like besides just I guess negation, right? So there's something called the converse of a conditional statement, and it's exchanging the hypothesis and the conclusion. So if you were to say, if your original statement was if a living organism has 46 chromosomes, then they're human, you would say if a person is human, they have 46 chromosomes would be the converse of the statement. To write the inverse of a conditional statement, you have to negate both the hypothesis and the conclusion. So this would be something like, using the same example, if a living organism does not have 46 chromosomes, then the living organism is not human. And lastly, to write the contrapositive, you are writing both the inverse and the converse. So this would be something like, if the living organism is not human, then the living organism does not have 46 chromosomes, would be a contrapositive statement. And these are just like examples for the statement. And now moving back into some math instead of basically statements, let's look at equivalent statements. So when two statements are both true or both false, they're called equivalent statements. So what I told you earlier, like if a living organism has 46 chromosomes, then they're human. It's an equivalent statement because they're either both true or both false. Next, let's look at the perpendicular line. So if two lines intersect to form a right angle, then they're perpendicular lines, right? So when you look at most things in a plane, you would know that this is basically how all right angles. So this would be a perpendicular line. And this is a notation for a perpendicular line. So remember that for proofs later on. And Lastly, let's look at some biconditional statements. So when a biconditional statement is a statement that contains the phrase if and only if. And anything that's really right can be written as a biconditional statement. It would be something like if an organism has 46 chromosomes, if and only if they're human, would be a biconditional statement. So if you're just trying to do something simple, let's look at 15, decide whether the statement is true or false. If false, provide a counter example. Just look at 15. If a number is a real number, then it is irrational. This would be not true. A real number can be something like 2, 3, 4, and they're all integers, and they are in fact rational. So this would be false. Let's look at using definitions 18 before we move on. So basically, you decide whether each statement about the diagram is true, and explain your answers using the definitions you have learned. So they're saying angle 2 plus angle measure 3 is equal to 180 degrees. Because we know the linear pair postulate, we can know that it would be 180 degrees. Seeing that's a straight line, so this would in fact be true. Now I think you guys can handle this, so let's move on to one sec. Yep, let's move on to 2.3 on applying deductive reasoning. When you think of deductive reasoning, you have to first think of proofs, and this is basically the first part of proofs. But first, what is deductive reasoning? So it's basically using facts, definitions, and accepted properties and the laws of logic to form a logical argument. And it's not like using examples, it's basically facts. So some things we learn, like linear pair postulate, vertical angles, concurrence theorem, would all be something that is used during deductive reasoning. Or even like the ruler postulate theorem would all, or like any other theorem would be deductive reasoning. But let's look at what the law of logic is. First, let's look at the law of detachment. So if the hypothesis of a true conditional statement is true, then the conclusion is also true. I think we already saw this in the previous section with the 46 chromosomes in human example. So this is basically the law of detachment. Let's look at the law of syllogism, right? So basically, this is in the saying if hypothesis P, then conclusion P, Q, if hypothesis Q, then conclusion R, if hypothesis P, then conclusion R. So if these statements are true, then the other statement is also true. So I know this may be kind of confusing, but you'll kind of get it later on. And it's basically saying in math, like, if this is true, and let's say this is true, then A is congruent to C would be obviously true, right? This is basically the law of syllogism at its core. And now let's look at some examples. Honestly, the section is pretty straightforward, but let's look at number 8. So if y is greater than 0, then 2y is greater than 0. So if 2y is greater than 0, then 2y negative 5 is not equal to negative 5. So you write here, it's saying write the statement that follows from the pair of statements that are given. Let's see, because y is greater than 0 and 2y is also greater than 0. If 2y is greater than 0, then 2y minus 5 will not be equal to negative 5. From here, we can also conclude that if y is, then we can also conclude that y minus 5 will also not be equal to negative 5, because here we can see it's the statement that follows up. And let's move on to our last section on postulates and diagrams. So this is basically like the first kind of taste of proofs you'll have, but let's look at these postulates. So these postulates have no name because they're not that important, but that being said, they're really basic fundamentals, so you should still know what they are, but there's no need to like memorize it because it's pretty much fundamental, right? Let's look at postulate 5 here. So through any 2 points, there exists only exactly one line. This is pretty easy. One line. And here a line contains at least 2 points. I think I already proved this too here previously. So if 2 lines intersect, then their intersection is exactly 1 point. Pretty clear, right? Through any 3 non-collinear points, there exists exactly 1 point. So dot, dot, dot. one plane. Oh, that's a bad plane, but you see the idea. So a plane contains at least 3 non-collinear points. Basically, you can't have this in a plane. That would be a line, right? So it has to be something like this, and that's a plane. If 2 points lie in a plane, then the line containing them lies in the plane. Obviously, if the 2 points are in the plane, the line would also be like something like this, right? Also, if 2 planes intersect, then their intersection is a line. Something like this, plane A, plane B, they intersect here. That's line C. There's the idea here. To straightforward, let's quickly look at perpendicular figures. So a line is a perpendicular line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that also intersects at the point. So something like this. Oh, that's a bad drawing, but basically, if it's perpendicular, it has to be perpendicular to every other like point in that plane. So if you look at maybe something like, let's look at like number 23. Use the diagram to determine if the statement is true or false. So JKM and KLM are congruent angles. Let's see. Angle JKM, JK, where's M? So this angle, and angle KLP, which would be KLP. So you're trying to determine if this is congruent, and I think this is pretty clearly not, because first of all, when you look at here, this is probably likely to be perpendicular. Same in all these angles, but if you see here, there is no proof of its congruent, and from what we know, like vertical angles and whatnot, it won't be congruent, because while here and here may be congruent, we cannot see a relationship to prove here and here is also congruent. So this will not be a congruent figure, especially because the angle here drops while it doesn't over here. Yep, I think this is it for today, and great job everyone, and I'll see you next time for 2 and 5, and to finish up chapter 5, 2 with some proofs. Bye! Thank you.